Let's take a look at this hypothesis test problem. Listed below are systolic blood pressure measurements taken from the right and left arms of the same women. So one woman's right arm is 102, her left arm is 175, etc. Use a .01 significance level to test a claim for a difference between the measurements from the two arms. What do you conclude? Okay, so let's get some information here. We know that we're doing a hypothesis test. We have test for the difference between them. So we're looking at the claim being the difference between them. Okay, so let's see. If we assign this as the first sample and the second sample, this is a two-sample problem. But since each of the samples are paired up, we would call this a two-sample paired data. And I'll write paired and capitalized so that we don't move to the two-sample t-test. We're not doing a two-sample t-test, we're doing a two-sample paired data. And this is actually going to reduce our problem to a one-sample problem. Let's continue on analyzing our claim here. It says that our claim is testing the difference between the two samples. So looking at their population, we are looking at mu sub 1 and mu sub 2, the mean for the right arms and the mean from the left arms being not equal to each other, since we're looking for the difference. Now, what we're interested in doing is combining this and pairing up the data. So we can subtract them, L1, or the population 1 minus the population 2. This is a 1 here. Let's see if we can write that neater. And so if we do the subtraction, let's subtract mu2 from both sides. We're going to get mu1 minus mu2 is not equal to 0. What we're going to do here is assign this to mu sub d. So we're looking for the mean difference between everybody's right and left arms. Okay, so now mu sub d is not equal to 0 is our claim. And as we're building our null and alternative hypothesis, we can write down that this actual claim is a not equal to symbol, mu sub d not equal to 0, therefore it will go in our alternative hypothesis. And so that would make our null hypothesis mu sub d equal to 0. Okay, so that is our statement, our hypothesis. You're making your claim and you're setting up your hypothesis. Now, back to this analysis. This is going to be a combined by subtracting. So when we subtract, you got 102 minus 175. I think this is negative 73. And 101 minus 169 might be negative 68, etc. Now, we can fill in this table a little bit later because we're going to let our calculator do our work for us. Anyways, once you get these numbers, you would find the mean of your sample, and that would be d bar. You also need the standard deviation for your sample, and that's called S sub d. And then our n, 1, 2, 3, 4, 5, n is equal to 5. Okay, so these are your statistics that would be important for us when we do our hypothesis test. Now, like I said, our calculator can do all these things for us, so instead of trying to find that separately, we're just going to punch all this information in our calculator, and we will perform our test as a regular one sample t-test, and the one sample that we get is going to be from here, whatever this list is going to be. Alright, I think we're ready for our calculators. So let's take out our calculator, and the first thing to do is input these data sets into our list. So stat, edit, and list 1 and list 2 will have these values. So I already typed it in. We got 102, 101, 94, etc., and paired up with 175, 169, etc. Okay, let's first figure out our second list, or our third list over here, which is going to be the difference between L1 and L2. So I have my right arm information in L1, my left arm information in L2, and I move my cursor up to L3 here, right arrow up there, and then here I'm going to type L1 minus L2. And so when I press enter, it's going to populate this with the information, with the difference between those values. So let's go ahead and take a quick picture of this, and let's put it in our notes here. So we can fill this in. I'll fill that in later. The next thing we want to do is we're going to go jump straight to the t-test, because in doing our t-test we will find all this information. Let's go ahead and get our calculator back, and let's do a stat test, and this is just going to be a t-test, so that's the second option. Now, like I said, we don't have the statistics, but we do have the data stored in L3, so let's select data, enter, and then our mu sub 0 is that mu sub d that we have over here, which is being compared to 0. And since we're using our data, it's in our list L3. Our frequency is going to be 1. And then now we're going to select the alternative hypothesis symbol, which is the not equal to. So let's go ahead and select that. Okay. Just for the sake of our notes, let's take a quick copy of that and put that slide over here. And let's go back to our calculator and calculate. And so we got the information that we need on this screen. So another screenshot. Look what we have here. We have our test statistic from our t-test, and this uses symbol t, which means we had used our t distribution, and we got a negative 17.33. That's a very negative number there. Our PV, which is our p-value, is 6.49, but this is e to the negative 5, so that takes that decimal point 5 places to the left, and so this is essentially a not exactly 0, but a number that's close to 0, so we can denote that with C plus or 0 plus, or we can put 0.00. Okay, we'll leave it at that. We also have the statistics information that we didn't really need to compute because our calculator did it for us. So we got a negative 72.2 as our mean. Our standard deviation, sample standard deviation is 9.311, and then our sample is 5. So here we go. We have our basic statistics, and we have our result from our calculator. So now we're ready to make our conclusion. Let's first make our decision. Since our p-value is what compared to alpha? Alpha is 0.01. Our p-value is a really small number, 0 plus, and then our alpha is 0.01. So our p-value is less than the significance level. We will reject the null hypothesis. Alright, so now what's our wording? So this is just the decision. We still need to write our conclusion in words. So it looks like our claim does not contain a condition of equality, and then we rejected the null hypothesis. So again, this table is very useful. Our original claim does not include a condition of equality, and we rejected a null hypothesis, so we must support the claim. Okay, so that's going to be our conclusion. The sample data, support the claim that, and we want to look at the claim. There is a difference between the measurements from the two arms. That there is a difference between the measurements from the two arms. Okay, so that's our conclusion. So it looks like there is a difference. And then we can just see that the left arm seems to have a higher systolic measurement than the right arms. Alright, now I know this doesn't ask for a confidence interval, but since we have our calculators out, we might as well do a confidence interval. Let's do a quick confidence interval. Let's go to stat and test, and we're looking at the t interval. So this is a z interval, so the t interval must be number 8. We can verify that, or we can just type in the number 8. Type in 8, and then we get a t interval. Now, because we had just done the t-test, it's going to keep the same information for us. And then we can use a 0.99 or 0.98. I think we can use a 0.99 to match with our hypothesis test, and then ask it to calculate for us. So this is a t-interval calculation. Let's get it in our notes here. And if you were asked to find a t-interval, you would say, I used the t-interval. And then the result was negative 91.37, less than the use of d is our parameter now. We're looking for the difference between the means. And then the upper is negative 53.03. So here, confidence interval does not include 0, so there is a significant difference. Furthermore, we can see that the confidence interval stayed to the negative side, and if we look at this, we have the first population, the right arm minus the left arm numbers, and since this is negative, the left arm numbers must be larger. So we can also add that to our conclusion. It seems like the systolic measurements from the left arm seem larger. Okay, so that's it. We got a hypothesis test, a confidence interval built in, yielding the same results, and that's how our hypothesis test works for two samples that are paired. We have paired data. Okay, hope this helps.